Hello, this is Mr. Klein coming to you from Klein Studios to teach you a lesson in statistical reasoning about something called experimental design. Today's video, I'm going to go through it quickly, and so I encourage you to pause, to go back when you need to. Just make sure that when you're done, you have a good understanding of this concept right here. I'm going to start by telling you something that I've suspected for a while. It's about this. And this. I have this theory that oranges cause excellent grades. And I want to find out if this is true. Now, using the methods we've learned in this class so far, if we wanted to answer this question, here's what we have to do. We'd use available data. Doing something called an observational study. Everything we've done in this class so far is an observational study. We've just observed behavior and then tried to draw conclusions from it. And so that's what this would look like in this case. We would take the test, and then after, we would ask, who ate an orange? And we would, we would be able to compare the orange group to the non-orange group, and we might even be able to show that there's an association, that students that did eat an orange did better on the test. But that can't prove that the orange is the cause. And the reason is that this right here is confounded. It's confounded with other factors about those students. For instance, a student that ate an orange in the morning was more likely to have eaten breakfast in general. And so maybe it's just eating breakfast that actually improves student performance. So we get this idea of confounding. Now, today we are going to fix that. Let me make one more note here. That's that when you have an observational study, like everything we've done, you can establish association, that oranges and good grades are associated, but not cause. So now, let's look at answering this question by an experiment. Now, when we do an experiment, what that means is that we are going to deliberately impose a treatment on our subjects. So, in our example, here's what that would mean. We assign students to two groups. The first group will eat an orange. The second group gets no orange. Okay, when we're done, we will take these two groups and we will compare their test scores. In this case, because we deliberately imposed the treatment on them, we didn't let them choose themselves, we can establish cause. And that's the value of experiments, that ability to establish the cause. So let me go through a little bit of vocabulary with you, starting with treatments. The treatments are what each subject is assigned to. So in the case of our experiment, there were two things that they were assigned. The first treatment was to eat an orange, and the second treatment, which we would call the control, was to eat no orange. All right, so those are our treatments. Next, let's talk about the response variable. That's the outcome that we're interested in. In the case of our experiment, the outcome that we're going to look at is the test score. Another way to think of that is response or respond. Students that have the orange might respond by having a higher test score. So that brings us to the explanatory variable, and that's what we deliberately change. In the case of our experiment, the thing that we deliberately changed is what students eat in the morning. So the orange or not orange. And again, it's because we think that they explain the response variable.